As we continue the emphasis on soil manipulation in an urban context, we'll consider next soils that are deliberately constructed in some situations and for particular purposes. Constructed soils have specific components added to achieve specific characteristics. Although street trees face many problems to grow successfully in the highly built-up urban landscape, the most significant one is the lack of usable soil volume for root growth. Research at Cornell University has resulted in a modified material that is a mix of soil, gravel, and water-holding polymer that meets engineering specifications for load-bearing but still allows tree roots to penetrate. This trademarked CU structural soil is a two-part system comprised of a rigid stone lattice to meet engineering requirements for the load-bearing soil and a quantity of soil to meet tree requirements for root growth. The structural soil has been used successfully in many settings across the United States and Europe. Another example of a constructed soil is provided by the U.S. Golf Association, which has developed detailed specifications for materials to be used to construct golf greens that will support healthy growth of turf. These specifications include details for subgrade, drainage, gravel, and intermediate, and soil selection including types of organic and inorganic matter that can be used, as well as detailing the physical properties of the root zone mix. The ultimate goal is to provide a good playing surface that withstands use by golfers. Constructed soils are also common on sports fields. Criteria for a constructed soil can include playability of the surface, supports of healthy turf growth, and providing traction and support for players. Between 1998 and 2000, extensive renovation was done to the Ohio Stadium on the campus of the Ohio State University. A new playing field was installed that required drastic modification of the soil, as the new field would lie below the normal water table of the adjacent Olentangy River. A new subgrade had to be established and engineering draining added. The prescription athletic turf system, seen on the upper right-hand corner, included 1. A specified root zone, 2. A drain mix, 3. A polyethylene barrier, 4. Water removed by gravity or vacuum-assisted drainage, and 5. A flat laser-leveled surface. Environmental monitoring stations throughout the field provided data on the moisture level of the root zone. They could activate the irrigation system if root zone moisture levels were too low. These could also activate the pumps that drew water through the drain and off the field if it rained during a game. The root zone mix consisted of 12 inches of a 90-10 specified sand-cum-till blend. Due to the high proportion of sand, the surface may have shown some horizontal instability and surface displacement. To alleviate this problem, the surface was stabilized with a natural and synthetic sod product called the Mott's TS2 stabilizer. The stabilizer sod was made from polypropylene fibers sewn in a 5-way blend of Kentucky bluegrass. The sod was established in Indiana in 1999 and brought in as big roll sod at the time of laying in July of 2000. The rolls at 3 by 30 feet were very heavy, which helped to knit the field together and kept the sod in place when the first game took place 6 weeks later. So constructed soils find use in a variety of urban situations that are meant to provide compatibility between the needs of plants and the needs of people in those environments. Another component of the urbanized environment is the use of artificial or soil-less media to support growth of plants not directly in natural soil. These include container plantings of different sizes used in a wide variety of situations. Container gardening has seen a dramatic increase in popularity over the past few years. Green roofs is another category of special urbanized environment where artificial soils are used to grow plants. Artificial soils, or also called growing media, are used to provide a balance of properties that support plant growth but that minimize weight. Green roofs are being used in a variety of settings to provide both water retention and infiltration that minimizes runoff. Most plants grown in greenhouses, and all plants grown in containers, whether in greenhouses or outdoors, rely on artificial soils to grow plants. The media used for growing plants indoors and in the greenhouse were once based on soil. This made them heavy and variable in composition depending on the source of the soil. Greenhouse media now have a base of organic materials such as peat, shredded bark or coir, often mixed with a light mineral such as perlite or vermiculite. The ingredients are selected to provide proper water holding, draining and fertility characteristics for good plant growth. Though other artificial systems exist for growing plants, particularly in the early stages of development, such material is beyond the scope of this unit. But it should be apparent that whatever material is used must provide the same necessary components and have similar characteristics to those of natural soils in its role supporting the growth of plants. Now, urban soils are often influenced more by human activity than natural soil forming processes. Some of the things that can happen include movement of material horizontally and vertically through excavation and grading. The natural sequence and continuous gradation from well-developed soil at the surface to subsoil and rock below can be changed or inverted, and there may be sharp transitions in texture and composition. Soils get covered with blacktop, concrete, or other impervious surfaces, but may still be expected to support plants. Native soil, particularly topsoil, may be removed and replaced with imported soil. Leaf litter is often removed so that organic matter is not naturally replenished. Unwanted materials such as construction debris, household waste, and other litter gets into the soil profile. On the positive side, soil improvers such as peat, compost, and mulch may be incorporated. Engineers often require soil to be deliberately compacted to improve its load-bearing properties. Vehicles and pedestrians also compact soil. After compaction, water and oxygen do not penetrate as freely, and this changes the structure, chemistry, and biology of the soil. Further changes occur through contamination with salt, used for ice removal, lime from cement used in construction, and a whole slew of urban pollutants. Conditions are generally worst immediately after construction. With care and over time, the patient can be restored to health and fertility, but the urban soil is likely to be very different from its ancestors.